Last week, we created a virtual instrument measurement system in LabVIEW. This week, we're going to do something just a little bit different. We will instead be using LabVIEW to model a second-order system with a PID control. This video, though, is going to focus on giving you a refresher on the basics of LabVIEW, as well as providing a few tips that will hopefully make completing this lab faster, easier, and less frustrating. First, remember that there are two unique windows with their own tool palette. So, you can see the front panel here on the right, which has the controls palette, and then the block diagram on the left, which has the functions palette. Remember, each palette has tools that are unique to it. So, when looking for a tool, be sure you are in the correct tool palette. Alright, let's take a look at one of the blocks you'll be using in this week's lab, the Special Transfer Function Model tool. First though, let's create a while loop, which is under Programming, Structures, While Loop. And then we drag it across. Remember, in order for things to be executed in a loop, they have to be physically located inside the loop box. Alright, so that being said, now let's add the Special Transfer Function Model tool. Alright, so that's under Control Design and Simulation, Control Design, Model Construction, and then here's the Construct Special Transfer Function Model. And we'll place that inside of our loop. So this week's lab uses a second order system, so I'll change mine to second order as well. Now we need to give this block three inputs: static gain, damping ratio, and natural frequency. A good shortcut in LabVIEW is to right-click the terminal, go to Create, and then go to Control. And you can see this made a numeric control with the name of the terminal that it was created from. This saves a lot of time when compared to inserting a numeric control, wiring it in, and creating the name manually. So let's create the other two controls as well. So go to the damping ratio terminal, right click, go to Create, Control, then go to the natural frequency terminal, right click, Create, Control. Notice that even with these four blocks, our diagram is already a bit messy and hard to follow. Lucky for us, LabVIEW actually has a cleanup diagram function built into it, and we can find that up here in the top menu. Let's see what it does. You can see it rearranges the blocks to better show the wire connections into the terminals. As your block diagrams start to get larger, this button can be a huge help. Now there's one last thing that needs to be pointed out. In LabVIEW, the block terminals have a color associated with them, which signifies what kind of data they either accept or output. So notice our transfer function block alone has 3 oranges, 2 greens, actually 4 oranges, and a pink. Alright, so the 3 most commonly used colors are blue, which carries numeric integers, orange, which carries numeric floating points, and pink, which carries strings. For more information on the color coding of wires, a quick Google search of LabVIEW wire colors will yield a page on National Instruments website with a table showing all the different types of wires.